Whoa. Wait just a second. Okay, so what questions do y'all have?
Page 908, number 19.
Okay. Oh yeah, it's 908, isn't it? Number 19. Okay, lottery. Okay. So 649 game player pays $1. It's like 6 numbers from 1 to 49. So winning numbers wins 1 million. Assuming that this is the only way to win, what is the expected value? So with this, I always like to make a table, like with amount that you win, and then the probability of that happening here. And in this case, I really only see 2 cases, right? You're either going to win big or lose much more often. So if you win, how much do you win? Let's talk about that first. What's the amount you win?
I said 1 million.
I don't think that's right. What do y'all think about that? You got to think about the cost to play a game. Usually games aren't free.
Would it be 900 or 999,999?
Does that make sense? Why you have to subtract that $1 cost?
Okay.
If you lose, how much do you lose?
$1.
Yeah, if you lose, you play the game, you play $1, so you lose $1. It's going to happen quite often. Probability of winning. What's the probability of winning? There's 649. We've learned, this kind of combines what we learned in earlier parts of the chapter. How do I calculate all the possible combinations there? With a lottery like that, does order matter?
No.
No. So we're going to use NCR, right?
Okay.
So what's my NCR there?
49C and then 6.
Yep.
Okay.
So get your calculator out, and then you do NCR 49, 6. And it's that big number there. So that would be 1 out of 139, 838, 16. So 1 out of 13 million, I guess. Does that sound right?
Yes.
Yeah, okay. And then the probability of losing would be?
Everything else.
Yeah. So like, I mean, 1, 3, 9, 8, 3, 8, 1, 5, I guess, over 139. You know, that same denominator there. And so now we're going to figure this out by doing again, it's always the amount times the probability. So you get your calculator out, and we're going to do 999,999 times the fraction 1 over 139.6. And then you're going to add, I guess, -1 times, and you do that 139. And I don't like that it gives me, put a decimal point to get a decimal there. So what's that mean when it says -0.92 there? I think that's the right answer. Is that the right answer? Did anyone check that?
I can check it. Yes, that's the right answer. Okay.
So explain to me what that means in context here, because I put it I rounded it to the nearest, I guess it'd be 93, I guess, to the nearest penny there. So So what's
For
that mean
every time you play, you lose 93 cents.
Yes, so every time you spend $1, you should expect on average to get about 93 cents back. You lose 93 cents, so you only get about 7 cents back. So that's not a very good probably way to spend your money. Does that make sense? Like that's not a good deal at all. Other questions? Anytime it's a negative value, by the way, it's not a good game to play mathematically. Does that make sense when I say that? Like this is positive, yeah, I'd play that game all day long. If it was 0, that's what's called a fair game. Does that make sense? So if your expected value is negative, it's not a good game to play. If it's positive, play it all day long. If it's 0, that means the game is fair. It's a fair game. Like you're not over. If you play it long, a lot of times, you're not going to lose money in the long term. You're going to about break even. Other questions?
Number 11.
Okay. So the bag contains 2 silver dollars and 8 slugs. So 2 silver and 8 slugs. You pay 50 cents to reach into the bag and take a coin, which you get to keep. And those are silver dollars. And it costs 50 cents to play. So again, I just like to make a table here. So always amount, probability of that happening. And then it looks like you can either win or lose here. There's only 2 options. So if you win, how much do you win?
$1.50.
Well, so there are 10 like coin type things in the bag, right? A bag contains 10 coins, so you get to pick one of them, I think, right? Which you get to keep when you take the coin. So if I pick $1, it costs 50 cents to play. So I pay 50 cents. I pick one of the coin looking things. And if it's $1, how much do I actually win?
50 cents.
Only 50 cents. So it costs 50 cents to play, you pulled out $1, you're happy, but you really only win 50 cents. If you lose, how much do you lose?
50 cents.
Yeah, because you're spending 50 cents every time. And then the probability of winning, how many winners are there out of 10?
2.
So 2 out of 10, and then 8 out of 10. And so then the next step you do is you get your calculator out and you type in, 0.5. Let's do that over here. So 0.5 times 2/10. You could simplify that if you want. Plus negative 0.5 times 2/10. And so I get negative 0.3. So my expected value is negative 30 cents. So that means every time I play the game, I spend 50 cents, but I'm really going to lose about 30 cents of that on average. So that's, again, not a great game to play there mathematically. It's got a negative expected value.
Okay, thank you.
Other questions?
Can you do 13?
Sure. So roulette, so it has 38 slots, 2 0 0 0, $1 bet, wins $36. Find the expected value of this game. So let's make our chart. So amount and probability. So I can either win or lose. It costs $1 to play, right? Let's see, $1 to play. And how much do I win if I what's my actual win if I cost $1 to play? How much do I win if I actually hit the right number?
$35.
Yeah, I think you're right. So it's kind of sneaky. You have to think about it. I cost $1. They do give you the dollar bet back,
Mm.
plus $35 is what it says. So 35 is my winning. If I lose, how much do I lose?
$1.
Yeah, I think this is, the winning, that's almost the hardest thing on the whole chart to get to usually. The probability of winning, it says there are 38 slots and only one of them's a winner. So 1 out of 38. And losing would be all the other slots, 37 out of 38.
The
And so
problem,
that,
though, it says like 2 slots are numbered 0 and 00, and the rest are numbered 1 to 36. And then it
right?
says a $1 bet on any number other than 0 or 00 wins $36.
Yeah, that is weird. Any bet on any number actually wins $36. You can bet 0 and 00. You get the same payback as betting 1 or I've seen roulette. I don't know
Okay,
why they said
because
it that way. That was really weird.
I understood it as like if you like the win is 36 out of 38. Does that make sense?
Oh, no. You have to hit the number correctly. Like if
Yeah,
you
that's
bet,
what I did too.
Yeah, I just think it was the
oh,
wording. I understood the example in the notes,
Mhm.
yeah.
but I just think this
Yeah,
problem was worded weirdly.
yes, it was worded really poorly. I'm totally with you. So you understand how to do it now
Mhm.
from this point.
Yeah, I thought it was weird when my answer was you were gonna gain $33. I was like, wow.
Yeah. Any other questions on homework?
Can you also do 17?
Sure.
That's the last
Plus the best 1,000 shares of risky stock for $5 a share. So amount and probability. This is probably the stock rise value to $20 shares, 0.1 other fall to $1 share, 0.9. Okay, so she spends like 1,000 shares for $5 a share. She spent $5,000. Do you agree with that? Okay, she bought 1,000 shares and each share was $5. So it cost $5,000 to buy all these shares. She estimated the probability the stock will rise in value to $20 a share is 0.1. So if it rises right now, that's at $5 a share. If it rises to $20 a share, how much money will she have? She spent $5,000 buying the stock. If it goes to $20 a share, how much money will she then have?
20,000?
Yeah, she'll have 20,000, which is a profit of how much?
15,000?
Yeah, 15,000 is her actual profit. If she loses here, and evidently losing, it will fall to $1 a share. So losing, it goes to $1 a share. How much will she have then? Like, let's see, she started with 5,000. If it's $1 a share, that would be
$1,000?
it's only worth 1,000. So how much did she actually lose in that case?
4,000?
So she lost 4,000. The probability it says of winning was what was it?
Oh, 0.1.
0.1. And this was 0.9, I think. And so then you do your like 15,000 times 0.1 plus negative 4,000 times 0.9. Your expected value is negative $2,100. Whew. So on average, if you do this, you're losing $2,100.
I was
Is that
just
what?
confused in their answer when they said $2.10 a share, and I was wondering just how you like get to that mathematically
But where's it say $2.10 a share?
in the back of the textbook.
Oh, because this is for 1,000 shares. And so 1,000 shares, so is worth negative $2,100. So if you divide this by 1,000, you get negative $2.10 a share.
Okay.
I don't think you have to write it that way. Like I would say your expected value, if you spend $5,000, you should expect to lose 2,100.
Okay.
Like there'll be a fine way to write your answer, unless they ask specifically for the share price.
Hmm.
Yeah, it just said what's the expected value. So to me, this is a fine answer right here.
Okay.
Anything else?
No.
Mm-mm.
And again, don't play this game, right? Like anytime the expected value is negative, it's I mean, like casinos, sometimes it's only like a 7 or 8 or 9% kind of take. You think, well, I mean, at least like it's not horrendous. Like a lot of these have been really bad. Like lotteries are horrendous for the odds. They're always against you pretty much, but lotteries are really bad. 92 cents. Oof, it's awful. Okay, have a good day. I've already got the quiz posted, so
Okay.
have fun.